Going, everybody. I'm going to try to make this as fast as I can. I want to see how quick I can make these videos. I don't want these videos to be like my first two videos. My first video was 30 minutes. Second video was 15 minutes. I want to make them shorter so you can learn and get the hell off my channel and go pass your test. Today I'm going to do food microorganism ratio. I'm going to flip right to, well, I should explain what the food and microorganism ratio, FTM ratio, F2M ratio, whatever people call it. Food microorganism ratio is a problem that you'll probably see on every wastewater test that you're going to take. Maybe not the grade 1, but definitely 2, maybe 3. Even the higher tests, like so. When you do these tests, there are different levels of these problems that they'll put on different levels of the test. So your grade 1 test, it might be, here's a bunch of information. Tell me how much food in pounds of BOD that you're going to, that with these numbers. Tell me the pounds of food. We give you this number, this number, this number. How much food? It might be, we give you this number, this number, this number. Tell me how many microorganisms, how many pounds of microorganisms you have in your system. And grade 2 test might be calculate the F to M ratio. Then your grade 3 test might be calculate out the food to microorganism ratio. Is that a good number? Then your grade 4 or 5 question might be what's the food to microorganism ratio? Is this a good number? If it's not good, how do you change it? You can ask the same question to a grade 1 and a grade 5 on the same test and just change the wording a little bit, and it makes it a more difficult problem. I drank too much Monster energy drinks today, and I'm a little shaky right now, but I'm gonna keep rolling because I don't want to waste that 2 minutes of my life. So I'm going to flip right around to this, and I got food to microorganism ratio here. Grab my mouse, do this. As you can see, I use freeware photo editing software to do this kind of thing. Your acceptable range of your food to microorganism ratio is 0.2 to 0.5. I mean, that's just something you got to memorize. I don't have any way for you to memorize that or anything like that. That's just facts. And it's a ratio. There's no units on the end here. Your food to microorganism ratio will just be listed as 0.2, 0.5, 0.3, 0.4, 1 if you're really screwed up, or that means you don't have any bugs, and 0.1 if you're starving your bugs to death. That reminds me, so the reason why you want to keep your food to microorganism from the 0.2 to 0.5 range is that the 0.2 to 0.5 range is the sweet spot. You want to keep it in a sweet spot. So if you have too high of a food to microorganism ratio, there's too much food for your bugs. They don't want to do work. They don't want to break things down. Food's right there. I'm just going to grab it. I'm going to grab this and eat it. I'm going to grab this and eat it. And I'm going to get fat and I'm going to get lazy. 0.1, there's no food anywhere. It's, I can't find food. I can't find food. I'm getting sick. I'm getting hungry. Your wastewater is going to get sour. You're going to get bad. Your clarifier is going to turn over. It's not going to be a good time. You want that 0.2 to 0.5. You want to keep them just hungry enough to keep them working, but you want to keep them well fed enough to where they're not dying. Calculate out this ratio by, this is why I made the pounds formula on my last video. You want your pounds of BOD or COD coming into your plant. I should have done some sort of video about what BOD is. BOD is not something where you go into a wastewater 1 class and they're like, this is what BOD is. BOD for this right here, it's how much food you have in your system. We're going to leave it at that. It's the easiest way for someone who's just starting out in the business to understand it. Your BOD equals your food right now. I'm not going to go further into that. The difference between the BOD and the COD test, though, is your BOD test is going to come in it's going to take 5 days to do. So if you're making plant changes, you may not want to wait 5 days for how your aeration basin was 5 days ago. If it's going to take me 5 days to figure out what my BOD is, you might end up having an upset plant by the time you can calculate this out and make changes. So the chemical oxygen demand test, COD test, is going to be a quicker test. It's going to give you a pretty similar number. It's not going to change anything. I mean, like, you run a smaller plant, though. I got a third-party lab, and they just give me an influent BOD every day. You know, they don't. I mean, that was blurry, but they just give me an influent BOD when we sample. It's a third-party lab. I put a sample into a bottle. I send it off. They send me a number. It takes me like 2 weeks to get that number. So in order to make changes, I may look at the average BOD for a month to calculate out my F to M and decide if I need to waste more or I need to waste less based on that number. Your mixed liquor, I mean, I could grab mixed liquor right now. I could, pour it through a filter, cook off the filter, and find out my mixed liquor number this very second. But if I'm going to take a month's worth of BOD samples and calculate this out, I might take a month's worth of mixed liquor sample and find a number that's nice in the middle. Because I might get 3,000 here, or 4,000 there, or 3,500 here. It all depends on what my return pumps are pumping at that point, because I'm running a extended aeration facility, and we're not always 100% consistent on what our return rate is and everything like that. It's a long story. I may go into it later. Here, your pounds of BOD or COD and your pounds of mixed liquor is going to represent your microorganisms, your bugs, what have you. Notice I put a bunch of stars after this because I wanted to point out that this number could change based on a number of things that I will go over in this video. So I got an example problem right here, and I'm not going to read it because I'm just not. You can pause the video right now if you want to do this problem. Note that there are 2 500,000 gallon tanks, not 2.5 million gallons of aeration. It's 2 500,000 gallons, not. Yeah, I should have put here. Actually, you know what? Now pause the video. Now pause the video. That is a lot less confusing. If they put a 2 next to 500,000, complain to the proctor and ask them what the hell they're asking, because I messed up there. That was me being lazy. I should have typed out all 3 letters. So I got this here. Call the parts of the problem, call it whatever you want. If you want to call it the top of the problem, if you want to call it F, you want to call it food, do it. You're always right. Don't let anybody tell you what to call nothing. You want to call it the F, call it the F, and you want to call it the M, call it the M. Do whatever you want. You're right, not them. You learn how you need to learn. That's the most important thing. If I could teach you one thing, learn how you learn. Don't learn how someone else learns. Food's how much we're feeding the bugs. It's pretty simple, Bugs got to eat, you got to eat. This changes depending on where you're feeding it. This is one of the stars that I was talking about. A lot of plants have primary clarifiers, a lot don't. If you have a primary clarifier could take 85, 90%. I had 80 to 95%. It depends on your clarifier efficiency. Dude, I ain't going to tell you exactly how every problem is going to be. I can prepare you for everything I've seen. And I've seen them in a bunch of different ways. I've taken ABC tests. I've taken California State Water Resource Control Board tests. I mean, you could see it in a number of ways. And the worst part of the way that they send the tests out is they will not tell you what to be prepared for. So be prepared for everything. Be prepared to use an influent BOD. Be prepared to use a COD. Recognize the difference between a BOD and a COD. Know that if you have a primary clarifier, I don't. At my plant, we don't have primary clarifier out there. So I'm using my influent BOD test. I don't have a lab to run a COD. And my city ain't going to pay me to go and drive an hour and a half to our lab to drop off a COD sample so that I can calculate a quick F to M tomorrow. You know, it's not going to happen. I mean, we have a town of 2,000 people. I can't be wasting tax dollars. You know what I'm saying? But if you have a primary clarifier, you got to use your primary effluent because that's what's being fed in. You're not using the influent because the influent's got a bunch of the BOD being removed and sent to the digesters at that point. So if you have a primary clarifier, use the primary effluent. If you don't have a primary clarifier, use your influent. I mean, I'm sorry that that's confusing. That's not my fault. That's going to be your test maker's fault. If you have a proctor that knows what's going on, ask them for clarity. See if they'll give you that clarity. If you're running an ABC test, they might just have someone in a computer lab running. She might not know, he or she, it's 2023, Frank. The proctor might not know what's going on. I say that because my proctor was female. I've never had a computer lab proctor be male because I've only taken one test on a computer. That was my grade 4 ABC. All the rest were done proctored via just a bunch of people. Because I was in big gymnasiums in California with a bunch of people sitting around taking paper tests. So I don't want to offend anybody. I just trying to get my point across. I got this example of a problem does not have a primary clarifier. I'll go over what to do if you have a primary clarifier later. You got your average flow. You want to take about math teachers, wastewater math teachers. Some wastewater math teacher will be all geeked out and they'll be like, it's not a true ratio because you're actually taking pounds per day and dividing it by pounds, and those units don't match, and you're losing a unit. And it's like, no. The redundant, you're taking your average daily flow. Your average daily flow is only expressed in million gallons. You're not taking your current flow rate of the plant. You're taking your average daily flow in this ratio. You're taking your concentration of your BOD or your COD. I forgot the units, but that's going to be in milligrams per liter, parts per million. If you want to go further into that, I just made a 15-minute video about that. I am way over on time versus my last video. Jesus. 8.34 pounds per gallon. This is the pounds formula. This is what I was talking about in my last video. If you don't know how to do the pounds formula, you're not going to be able to do F to M. Go watch the pounds formula video. I mean, I got it broken down here. From the problem, you should have it. The top part of your problem should be 0.664 million gallons times 226 milligrams per liter. And you're 8.34. I got that calculated out to 1251 pounds of BOD. Your microorganisms. Again, you can call it what you want. Some people will have you calculate out the bugs in your secondary clarifier. I think it's stupid. I'll explain. I've already been doing this for 15 minutes. So some problems will say you have this much in your aeration basin. You have this much in your secondary clarifier. I hate this so much. The bugs in the secondary clarifier. The reason why I think it's dumb, and you might see it, so you need to be prepared. Don't not study how to do that because I think it's dumb. Don't do that. because that's bad. That's bad. I probably shouldn't be telling you, hey, this math is stupid. But this math is stupid because those bugs in the secondary clarifier are not eating. They are settling out. They're getting ready to go to the digester. They're getting ready to be returned back through the activated sludge system. They're not eating at that point. You're not feeding them. This shouldn't be a part of the ratio. Some problems will make it part of the ratio. I do not agree with making it a part of the ratio. And my smart butt did not put the freaking answer to the test on this slide, and so I'm doing it on the fly, and you'll see how sloppy it looks. So your microorganisms, this is the bottom part of the ratio. You got the volume of the aeration basins, the concentration of the mixed liquor, suspended solids, that's what that MLSS stands for. It's your milligrams per liter in your MLSS. 8.34 pounds per gallon. We can't forget that on one side of the problem or you're going to throw off your ratio. So I got 2 500,000 gallon clarifiers. That's just one. When you put that in the calculator, you're just putting a 1. Or if you're really good at math, you don't even put it in the calculator because you're doing multiplication. You got your concentration in the mixed liquor, 7,500. I have a typo there. That's MGL/L. 8.34. Don't forget it. And you got, this is how many pounds of mixed liquor. 62,550. What you need to do, divide the two numbers together. I got a rough 0.02 for my, you see my handwriting there with the mouse. Great. Just great. So that's how you do it. If you got the right answer, you did the problem right. Good job. Good job. If you didn't, figure out where you messed up. Go through it again. Try to figure it out. Because if you find out where you messed up and what you missed, or maybe you only used one of the aeration basins. Maybe you forgot an 8.34 somewhere. Maybe you used the wrong concentration on the top and the bottom. You got to get the right concentration on the top. That's your BOD. That needs to be on the top because that's your food. BOD is food. Bottom has to be what's in your aeration basins. That's what's in your activated sludge system. It's your food to microorganisms. It's not your microorganisms to food. Maybe you have your million gallons wrong. Maybe you did use both aeration basins, but you took the 2 aeration basins and you put them on the top of the problem, and you put the and you took the daily influent flow and you put that on the bottom. If you did that, you messed up. Figure out where you messed up. Do it again. Figure it out, because you're going to have to do this on a test eventually. All right, so I got of this formula right here. Problem number 1, they give you a primary effluent COD instead of an influent one. Solution, you just use the primary effluent instead of the influent. This is an easy one. If that's common, you might see that. That's okay. I'm not mad about that. Number 2, they give you the influent and the primary effluent. They're trying to trick you. Just use the primary. They're trying to trick you. It's BS. I don't think they should try to trick you on the test. They should just see if you can operate a dang wastewater plant. Why do they got to try to trick you? Test shouldn't be a trick. Shouldn't be a trick. Just find out if I know it or not. Don't try to trick me. I'm trying to just get my certificate and put it on the wall, man. Don't try to trick me. Don't give me numbers that I don't need in the problem. I don't need the influent if I got a primary clarifier. Don't try to trick me. That's messed up. I don't like that. Makes me mad. Second one, they give you a clarifier volume. Make you add it into the microorganisms. I don't like this. I ranted about this already. I'm getting mad again. All you do, just combine the 2 volumes with plus it. If you got 1 million gallons of aeration and 1 million gallons of clarifier, just do 1 plus 1, make it 2. I don't like that you're doubling the bottom of your equation because you're cutting your F to M ratio in half. I don't like it. Yeah, you can see here, I was mad when I was typing this out. I'm moving from this state once I get reciprocity. Because whoever wrote this test is just, I hate you. I hate you. I hate you. I hate you so much. I put this one in at the end, and that's why it's not lined up or nothing. They give you... Oh, man. Sorry. I'm not editing it. I'm not editing it out. I'm not doing it. I'm coughing. Coughing. Get over it. I'm a human being. I'm not a robot. This is not an AI generated video. They give you a % volatile solid. All you have to do, if it's 90% volatile, you need to multiply that by your concentration. I have to explain what's going to take. Let me just get something to drink here real quick. One hand in it. My goodness. See, the problem is I'm not going to say who did it. But this dried the heck out of my throat, and I do not like it one bit. Do not buy this if you live in the Midwest. It is gross. I did not pay any money for this. I won it in a promotion. I'm drinking it again. It's probably not going to help. The % volatile solids. At a larger facility, you're going to have a way better oven than my lab has. My lab dries out the filter, and I can measure how much solids is in it by drying it out. Some places will have an oven that gets way hotter, and it will burn off everything that can burn off. Everything that doesn't burn off is what's called inert solids, INERT. So you use the volatile solids because the volatile solids will more accurately represent the bugs in your clarifier. So if like in that example, you have 90% volatile solids, the bottom of your problem is actually more accurate if you use the % volatile solids. I won't get mad at a test maker for adding a % volatile solids into an F to M ratio problem. All you do, this is a good thing. If you have that equipment, it's much better to use. You may see it on a test, you may not. % volatile solids, you have to convert that into a decimal. You can't times it by 90 or else you'll have freaking 900,000 milligrams per liter. You'll have 90% sludge. It's probably not good. I don't think you'll be getting proper aeration in your aeration basin. 90% sludge. So you convert that, you divide that number by, or you move the decimal over 2, divide it by 100. Because remember that %, if you ever took a math class, that % means it's 90 over 100. So it's 0.9. Don't forget your 8.34.